Hello. In this video, we're going to take a look at this problem here. Again, the key idea as a teacher of what I'm trying to check that you can do here is I'm trying to see if you can use a loop to look at a string. Really important skill. So our method is called catThere, and then this is an example of what we pass to the method, and this is what gets returned. So if catThere is passed A, B, C, C, A, T, we see that cat appears once, and so therefore it returns true. If catThere is sent C9T, we return false because the word cat doesn't appear. If catThere is passed BAC, it returns false because, again, I don't see an instance of cat. So what I need to do, and let's come over here and let's take this first example. Let's change my color to green. And so in the first example, ABC, well, this is red, but that's okay. ABC cat. So the way this essentially works is I'm looking for the word cat in the string. And I can do that by starting at the very first element. I'm just putting the indexes on here. And if I start here at 0, I can look at these three letters and say, is this cat? If those are cat, then I know that cat exists. But if it's not cat, I can move this red line up one position. So I can go BCC, and I can ask the same question, is that cat? Well, no, BCC is not cat. So I'm going to move up the line, CCA, and say, is that cat? Well, no, that's not cat. So I'm going to move up the line and look at CAT and say, is that cat? And the answer is yes. So as soon as I find that there is one instance of the word cat, and there it is, I can return true. That in fact this string does contain the word cat. Well, let's make another example that's different than what are the ones up here. But let's not have the word cat in here. So let's call it A, B, C, C, O, W, ABC cow. So I'm going to do the same thing. I'm going to start by looking at the first three and then say, is that cat? No. Then look at the next three. Is that cat? No. Then look at the next three. Is that cat? No. And then look at the next three. Is that cat? No. And now this is where I have to be careful. Because if I decide to look at the next three, I'm going to run into this weird problem here. And what that problem is that if I move collect this kind of line up another space, I'm looking at OW, nothing. So if I try and access that, I get what's called an index out of bounds error. So what I need to do is set up my loop, and let's number these again, so that it counts through the positions that the start of this line should go to. So 0 is a valid one because I'm going to go 0, 1, 2. 1 is a valid one because I'll go 1, 2, 3. 2 is a valid one because I'll go 2, 3, 4. 3 is a valid one because I'll go 3, 4, 5. But notice 4 isn't valid because then I'll go 4, 5, 6, and there's no 6 index. And also 5 isn't valid because I'll go 5, 6, 7. In that case, 6 and 7 isn't a valid instance. So if the length of my string is 6, I only want my counter I to get to 3. And we can, of course, work that out as a mathematical relationship in terms of the length of the word we're looking for. So what I do here is I declare a string called T, and I put nothing in it initially. And then I create a loop. And so again, if I come back to this example here, I'm going to start at 0. I'm going to work my way up. So I is 0, and each time I see that I is increasing by 1. I've left this for a second. We'll come back to it. So what do? The first thing I do is I take the string T and I get a substring. So I use the substring method and grab the 3 letters starting at I to I plus 3. And then I say if T dot equals cat, so essentially I'm asking, is the word, those 3 letters cat? I return true because I can stop. I'm done. But if it's not cat, I come down here and I increase I by 1. So I want to continue increasing I until I can't get any more 3-letter words. So here, again, in this case where the length is equal to 6, I needs to get to 3. So if I come up with another example, let's go A, B, C, D, E, F, G, H, I, J. So the indexes here, 3, 4, 5, 6, 7, 8. The indexes are 0 to 9, and the length is 10. So in this case, the last place I'd want, the last 3 I would evaluate would be right there. So the I want that to get to is 7. And so the I want to get here is 3. So what I ask myself now is, so if I'm trying to find a relationship here between the length of the word I'm looking at and the I value that I want to reach. So I notice in each case it's going to be the length minus 3. Notice, so 6 minus 3 is 3, 10 minus 3 is 7. So there's 2 ways I typically think about setting up this. Some students it's really useful to say I is less than or equal to the string length minus the length of the word that I'm looking for. So cat is 3 letters long, so I is less than or equal to the string length minus, less than or equal to the string length minus 3. But often people will do it this way. They say I is less than string length minus 2. Because I could say, there's 2 ways I could say this. I could say that I has to be less than or equal to 3, or I has to be less than 4. Either of those is valid. I hope this video adds some clarification.